etc. We will be studying. Okay, it is an integrated course, means theory plus little bit of practicals. It is not completely a laboratory course. Okay, a small portion of preferably demonstration. Say for example, we will study here sound dream breathing working exercise. Any one of the exercise we will be demonstrating in the laboratory. We will be studying about turbines here. Various turbines, how they work. One of the turbines we will be demonstrating the working in the laboratory. We will be studying about IC units. What is the so one engine concept between the device during the lab. Okay. So it is an integrated course. So today to start with, we will discuss what are all the topics that are there in the syllabus. Okay. And how the assessment is as per coming to module 1. So in module 1, we have to discuss about mechanical engineering. Why is it important? Okay. So what is the direction? What is the contribution of mechanical engineering to society? Okay. So when we start analyzing this one, you can feel that every day one or another so how it is related? We need to study then steam formation and application. This steam is one of the important components. Okay. In many of the power plants and processes, the only way to get the electricity is by steam. For example, you might have heard about RTUs, High-Speed Thermal Power Station, right? From where we get maximum power. So how the electricity is produced there? From coal. They burn coal, whatever energy they get out of it, it will be converted to electricity and through grids they will supply to the grid. Okay. So how this coal is getting converted to electricity? First thing is they burn and produce heat. How the heat is getting converted to electricity? Again, this heat is supplied to water in a boiler. Okay, what happens to water when you start heating? You start see if it is an open vessel at your home. After some time you can see that bubble starts floating up, then steam will be formed. If it is completely steam vessel, steam will be accumulated. This steam through pipelines it will be supplied to a turbine. The turbine in simple words I can tell you, it is just a beam with certain shapes of different shape. When something hits it, say for example, you can take this, right? So there is a central beam with some amount of gauge. It is a current where you are supplying additional power, so there might be flat. If you want to generate power from it, it will be a bowl shape. When somebody hits this bowl, it starts working. Right? So that mechanical energy will be produced. Mechanical electricity will be produced. That either will be supplied to a generator. Right? So in generator, electricity. So you consider either a nuclear energy, wind energy. Steam is important. So producing the steam. So the steam acts as a bridge between conversion of one form of energy to another. Initially, what do we have in this example? We have coal. Right? It has some chemical energy. When you light a fire, it can give out its chemical energy in the form of heat. Right? So that heat, in the process of conversion to electricity, we need some bridges. We need a postman to carry from here, putting into the generator. Generator cannot take up the heat. In such applications, steam is important. You can see here, we will be studying about thermodynamic properties of steam, how steam is formed, what are its properties, then applications of steam will be studied. Almost in any industry, if you start noting this, everything you use in life, directly or indirectly, it will be connected to the steam. Right? Next, power plants, we will be studying about different types of power plants. What do you mean by power plant? It is a central generated electricity. Because the entire world is relying on electricity. If you don't have electricity per day, you cannot run this class. If I don't have a projector with a chalk and talk method, it will take 3 hours or 4 hours to demonstrate these things. Everywhere electricity is there. And today's you know very well IC whatever petrol diesel engines they were using, all these things are almost becoming obsolete. Another 10 years, 70% of the vehicles will be of electricity. Correct? So electricity is a prime application from which which sources can you produce electricity? Hydel means water. From water, how can you produce it? Thermal means heat, chemical energy, coal, whatever we discussed. Next, nuclear energy, solar, tidal, tides that are formed in the ocean. They have very good amount of energy. Then wind, blowing wind. You might have seen windmills in many places. Even Dabaspete, if you visit industrial area, huge mills will be kept, blades will be kept. So different types of power plants we will be studying. And the last one will be turbines and pumps. Just we will be touching the surface, how a turbine works. What are the different turbines? Okay. So this will be module 1. Now I think once you start looking at the syllabus, you can analyze every point somewhere, whatever we are using is directly or indirectly related to mechanical engineering, right? In module 2, it's more of materials. Okay. So in the first part, we will be studying about different types of materials like metals, ceramics, composites, etc. Why should we study about these materials? See, one example, I'll give you. I want my laptop to be as thin as possible. It is very light. I should be able to carry it like a book. So what are the constraints that will be there in designing? The first constraint is huge amount of heat will be generated by this. That too, when I am using it to an external source like this, it will be boiling like this. I need some material which can throw out the heat at a faster rate. Use the plastic here, what happens? Definitely it works for that. Correct? When I keep it for charging and use the projector, its temperature is 50 degrees. Correct? I need some ceramic based material which will be very much aesthetic to see. People will buy it. Nobody will pay money otherwise. And also my functionalities like dissipation of heat, it should be scratch proof, it should be aesthetic, everything should be met. Is it possible with old and new metals? It's not possible, correct? So you should have a basic knowledge of different materials. So ceramics are the most upcoming materials for such. One more example I will give you. How you want to design an outline for a aircraft. What is the objective? It should take huge amount of stress. Correct? Say when you are going with 400 or 500 kilometers per hour, just imagine driving a car at 100 kilometers per hour. Just open the window. What will be the breeze speed it comes? Correct? Imagine a 500 kilometers per hour, 1000 kilometers per hour. The material you use should be highly stress resistant. Correct? Whatever load you put up, it should be. What should be the second criteria? It should be as light as possible. Correct? Since it should be stress resistance, I cannot use a 25 mm or 30 mm metal sheet to build a aircraft. Correct? If it is heavy, you cannot fly. Correct? So we should have some basic knowledge of materials to enter into any production unit. If you are designing an aircraft, no issues. You want to load, let's say, 7 tons, 8 tons, 15 tons. Whatever you can make the load, only negative part will be its efficiency will come down. If it is very stealthy, correct? If you use a clear button. Yeah, but in a aircraft, you cannot use that formula. Okay. So in the second module, we will be studying more of materials and how to combine this material. Right? How to make it into a part. You want to aircraft, say, cylinder. Okay. Where passenger is not be a single mold, single component. Right? Number of sheets you can get together using various processes like soldering, brazing, welding, etc. They are all understand the joint things. Okay. And lastly, about some of the heat transfer applications. Okay. So there are some modes of heat transfer like conduction, convection, radiation. Okay. When we come to that one, I will explain to you some live examples. Okay. So before that, one question I want to ask you. I have a cup of coffee at 65 degrees. It is very hot. Okay. I keep it open in the table. Why does it get cold after some time? What is the process that is making it cool? Okay, I'll take 2 cups of coffee. One I keep it here where there is no fan breeze. Second one I keep it directly under the fan. Okay, after 1 minute I measure the temperature. This might have reached 60 from 65, but that might have reached around 50. It might have cooled at a faster rate. What is the making it cool? It gets cooled and everybody knows. What is the phenomena that is happening? See, if I give hot and cold, what everybody knows. And energy transfer takes place, direct connection means the temperature level. I'm not using anything here. What is the process that is making it cool? Such things we will be studying in this. Okay. So what are the modes of heat transfer? Why that liquid gets cooled? Why this knowledge is required? You might have seen a radiator in front of their car. That's what you have to like. You want to radiator, you might have seen. Okay. Every now and then cooling liquid, every 5,000 kilometers or so. What is the job of this radiator? Whenever overheating takes place, it has to cool it. So what is the mechanism that takes place there? The same compound mechanism. All this, whatever I have listed here, like radiators, condensers, evaporators, etc., they are all heat exchangers, which will transfer heat from one component to another. From your engine, it has to take away the heat and it should throw out the oil. Okay. Like that heat transfer application. Is that just the coffee question, whatever I told you? I just explained you. I have a cup of coffee as I told you. Okay, there is no fan over here. First case, okay, it is at 65 degrees centigrade. So what happens? The atmospheric air, which is in contact with the top layer of coffee, will be at, say, for example, 30 degrees centigrade. Like today's weather, if we take it is around 30. So what happens when the air comes in contact with the coffee? Obviously, heat flows from hotter medium to colder medium. Correct? Yes or no? It's law of nature. This air, whatever is there, it takes up the heat from the top layer of the coffee and it passes away. Correct? So once the top layer loses the heat, it will tend to come down. Why? Density. Just think and tell me, you take the example of hot water and steam. Hot water will be very dense, whereas steam will be lighter. It tries to float. So what happens here? The next layer of coffee comes over here. Over a period of time, the air keeps on taking the heat. This is called as convection. Heat transfer by convection. Suppose I have a fan over here. What happens? Here, the air has to come here. It has to take the heat. Once the heat is taken, it should become lighter. Then, since it has become lighter, it will try to float so that the fresh air has to enter. This will be a slow phenomenon. If I have a fan over here, forcibly air will be blown to the coffee. It can pick up heat and it will be rushed away. Whether it picks up or not, it will be kept on throwing at a faster rate. So air circulation will be more. The first example, whatever is there without fan, we call it as natural convection. Naturally, it is happening because of density difference. Whenever I switch on a fan, then have a medium, not only fan, any medium. Okay, with fan, that is called as forced convection. Some forcing mechanism is there to carry away the heat. Such heat transfer concepts we will be studying here. I think now you can analyze everywhere concept of mechanical engineering in your home will be there. Anything you take your refrigerator, definitely it gets heated up. Correct? See, it's law of nature. When you want to keep a component cooler, obviously the heat should be taken and it should be thrown somewhere. Correct? There also these concepts with condensers, evaporators, etc. You take your air conditioner, your room will be cool. Just go near the condenser, which will be outside evaporator. You can feel the heat. Right? So such applications we will be studying here. Right? Now, coming to module 3. In the first part, we will be studying about vehicles, automobiles. Right? So the first topmost part is the IC engine. What do you mean by IC engine? Internal combustion engine. Inside the engine, combustion means burning of chemicals. Similar to the coal example, either petrol or diesel, whichever you take, it will have some amount of chemical energy. When you light a fire there, it will burn out and give out heat. That heat will be since it happens in a closed box. This one is internal combustion. The other diesel had an external combustion. They used to burn the fuel in a separate compartment. Whatever steam is produced from that, that was used to drive a generator. Okay. That is an example of ECE.